The name of today's film is called Nomenclature, and nomenclature is the way we name compounds. Binary compounds are made from just two elements. There are three types. There's binary ionic, type 1 and type 2, and there's binary molecular, which are called type 3. Today's film is going to focus primarily on ionic compounds, the type 1 and the type 2. They're made from at least one metal and at least one nonmetal. In another video we'll talk about molecular compounds, type 3. They're made from two or more nonmetals. Type 1 again, ionic, are made from at least one metal and at least one nonmetal. To name these compounds, we simply name the ions they're made from. For example, NaCl. Na is sodium, sodium ion, and Cl as an ion is called chloride. This becomes sodium chloride. The compound below it, Ca, is calcium, Br is bromide. It becomes calcium bromide. Notice we didn't even mention the 2. Not necessary. It's simply called calcium bromide. Next, I want to name this compound found in toothpaste, NaF. To name it, we need to know the names of each ion that make it up. Referring to this periodic table, Na is number 11. On the left-hand side of the periodic table, it's a metal, and F- is called fluoride. It's a nonmetal. It's on the right-hand side of the periodic table. So this compound becomes sodium fluoride. Again, it's put in toothpaste to harden our teeth. Let's try another one. This compound, Ki, is found in supplements, mineral supplements. Iodine is good for our thyroid gland. Potassium is good for our nervous system. Let's look at the periodic table again. K is a metal. It's found right here. It's potassium. It's a +1. And iodine is over here. It's a nonmetal. It's on the right-hand side of the staircase. It's called iodide. It's I-1. So let's name it. This becomes potassium iodide. Potassium iodide is the name of this compound. Got an extra thing there. Okay, potassium iodide. Let's try another one. This time we're going to try type 2 binary ionic compounds. Type 2 are different. Let's go back a slide. They're different because the cation, the metal can have more than one charge. And when that happens, we must give the charge in the form of Roman numerals in the name of the compound. Let me show you iron on the periodic table. Iron is in the middle here, right there. It can be a +3 or a +2, +3 being more common. The one on top is more common. So, we also need to look up oxygen. Back to the periodic table. Oxygen is a nonmetal. It's right there, O-2, or 2-, same thing. It's called oxide. So remember, we need to say which of the irons we're talking about. Oxygen's charge is a -2. Remember that. So back here, if oxygen's a -2, then to be a neutral compound, which all compounds have to be, the iron has to be a +2. So the Roman numeral 2 reflects the +2 charge in the iron. So it's iron 2 oxide. The iron we're referring to is the lower iron, the one on the bottom. Let's try this slide. There are two types of lead oxide. To the periodic table, remember that oxygen is always a -2. Lead is in this area of the periodic table. It has two possible charges. It's kind of small for me to read, but it can be a +2 or a +4. In my slide, I can't tell which is more common, which is on top. Doesn't matter. Let's go back to this slide. Here, if oxygen's a -2, this lead has to be a +2. Again, all compounds have to be neutral. So this becomes lead 2. Oh, my screen needs to be bigger. Lead, Roman numeral. Not gonna let me. 2 oxide. Sorry for the technical difficulty. lead 2 oxide is this yellow powder. This next one down below, it's an orange powder, an orangish red powder, and it has a different name. It clearly needs a different name because it's a different compound. It's a different color at least. Now remember, oxygen's a -2, and there are 2 of them. Together, 2 -2s would be a -4. So to be a neutral compound, this lead has to be the +4 variety. So the name becomes lead, Roman numeral 4, oxide. To review, that 4 tells me the charge on the lead. Oxygen's a -2, there's 2 of them, that's a -4. That makes that lead a +4, lead 4 oxide. The reason we have to use Roman numerals is because they're clearly different compounds. They need different names. In closing, just a little bit of history. Lead salts are very colorful. And because they're colorful, before 1978 they were used in all kinds of paints to give them pretty colors. The problem was it was found that kids were eating those chips of paint, and by eating them, having brain damage. So in 1978 the federal government required that all paints be made without lead-based salts. Well, that's the video for today. We learned how to name type 1 and type 2 binary ionic compounds. Type 1, you just name the ions. In type 2, you need to use a Roman numeral to tell which type of positive ion you're referring to. That's it.